Day in and day out, irrigation valves operate in tough conditions. The filter sentry mechanism is a critical feature available to optimize the performance of high-pressure Hunter valves. In this video, we'll identify the different components of a valve, including those visible on the outside as well as those on the inside. Next, we'll illustrate the path that water takes through the valve. Finally, we'll demonstrate how the filter sentry mechanism works to help keep your irrigation system operational, even in the most challenging water conditions. The ICV valve is our most popular valve for larger irrigation systems. This forward flow valve has several key features that make it an ideal choice for demanding projects. Before we move on, let's cover some basic facts. There are two basic types of irrigation valves: forward flow and reverse flow. Hunter valves are designed to accommodate a forward flow in which water flows up from under the valve seat. In reverse flow valves, water flows over the valve seat. There are advantages to both types, but forward flow valves are generally better in low flow installations. Install the valve properly into the piping system in an easy access valve box. Use waterproof connectors to wire the valve to the controller. Most irrigation valves work with the same basic principles. So, although there are some minor differences, the information presented in this video applies to most common irrigation valves. The lower portion of the valve that contains the inlet and outlet is called the valve body. It adds rigidity and structural strength to the valve. The removable top portion of the valve is called the bonnet. Bonnets are generally held on by screws, but the ICV uses bolts that mate with a threaded brass insert in the valve body. ICV valves also have a flow control handle on top of the bonnet. The handle regulates how far the diaphragm can move up and down when water is flowing. The flow control decreases the flow and decreases the pressure. A manual bleed screw on top of the flow control handle can be used to manually open the valve. The solenoid is the electrical component of a valve. It receives an electrical signal from the controller that lifts a plunger from the solenoid seat to activate the valve. An optional feature available on some valves is a pressure regulation device. Here, you see a Hunter AccuSync pressure regulator, which is compatible with all Hunter valves. This easy-to-install device regulates pressure to optimal levels, saving water and maximizing the life of the system. If we cut the valve in half lengthwise, we can examine the internal components. Here, we see the inlet and outlet of the valve, the bonnet chamber, and the valve seat. The diaphragm is the movable assembly inside the valve that serves as a seal between the bonnet and body. It moves upward to activate the valve and allow water to flow, and downward to close the valve and stop the flow of water. This spring helps the diaphragm close when the valve is turned off by assisting the water pressure in forcing the diaphragm down. This valve has a filter screen on the bottom of the diaphragm assembly that filters the water flowing to the upper chamber of the valve. This plastic support ring rests inside the valve body. It supports the diaphragm when the valve is in the off position. The valve has several ports that allow water to flow internally: a metering port, a bonnet exhaust port, and a solenoid exhaust port. The metering port controls how fast the water enters the upper chamber of the valve, which determines how quickly the valve closes. The bonnet exhaust port allows water to exit the area above the diaphragm, which causes the valve to open. The exhaust port is larger than the metering port, so the water leaves the bonnet chamber faster than it can be replaced, allowing the valve to open. The solenoid exhaust port allows water to enter the downstream piping when the solenoid is activated. Filter sentry is a vital addition for irrigation systems where debris is present in the water. Streams, ponds, and other non-potable sources, including reclaimed water systems, are common sources of water in this category. In Hunter ICV valves, the standard diaphragm has a sturdy nylon screen positioned in the path of the water flow. This screen keeps any debris in the water from traveling into the upper diaphragm chamber through the metering port. In ICV valves equipped with the filter sentry mechanism, it's attached to the lower part of the diaphragm. There are two parts to the mechanism, a stainless steel spring and a plastic wiper. They surround a robust stainless steel filter screen. Filter sentry comes standard on all brass Hunter IBV valves, due to the heavy-duty conditions where these valves are usually installed. Although filter sentry can be ordered factory installed on any Hunter ICV valve, it can also be easily retrofitted as needed in the field by purchasing a new filter sentry diaphragm assembly. The filter sentry mechanism is activated when water begins flowing through the valve. When the valve opens, the water pushes upward on the mechanism, causing the spring to compress and enabling the wiper to scour the surface of the stainless steel screen. Any debris on the screen is scrubbed free by the action of the wiper and moves downstream from the valve. This process continues if water is flowing in the valve. The innovative design allows the entire screen to be scoured by the wiper, regardless of how much the diaphragm moves up during operation. When the valve closes, the wiper returns to its original position. When a valve is full of pressurized water, the pressure is equal on the top and bottom of the diaphragm. Since the surface area of the top of the diaphragm is larger than on the bottom, more force is applied on top to keep the valve closed. What causes a valve to open? When the controller sends an electrical signal to the solenoid, it creates a magnetic field that draws the metallic plunger up off the solenoid seat. This allows the water that's on top of the diaphragm to exit the bonnet chamber and flow through the exhaust ports toward the downstream piping. This makes the pressure on top of the diaphragm lower than on the bottom, allowing the diaphragm to lift off the valve seat and opening a path for the water to flow through the valve to the piping system. Hunter valves can also be opened manually by turning the solenoid a quarter turn counterclockwise to lift the plunger off the seat. The bleed screw on top of the flow control handle can also be used to evacuate the water externally from the bonnet chamber, allowing the valve to open. Depending on the method used to open the valve, reversing the operation will cause the exhaust port to be closed. This will allow pressurized water upstream from the valve to flow through the metering port to refill the bonnet chamber, creating the force required on top of the diaphragm to close the valve. It's important to understand the components of an irrigation valve and how they work. Having this knowledge will simplify installation and maintenance in the field. As you learned, Filter Sentry provides important benefits to optimize the performance of the valve. You'll want to install Hunter valves equipped with this feature on any jobs that irrigate using dirty or